Good morning, everybody. My name is Erik Morten Blixt. I'm Dr. EM from Blueback Reservoir. I'm here to show you how you can do some simple 1D forward modeling in the Bridge Electromagnetic plugin for Petrel. So we're going to simulate the controlled source electromagnetic response of a simple 1D resistivity model, and you can use this to quickly address the feasibility of your model. So in this typical example, or this example, we're going to use a well log, which we have blocked to make it more coarse, which is more suitable for EM simulations. And we're going to simulate the response to gain a typical magnitude versus offset plot, which is this kind of bell-shaped curve. And also a typical phase versus offset curve. So let's jump into Petrel. So here you have the well in question, which has some high resistivity values down here. And I'm going to use that as input. Here is the well section window where you see the raw well log, and here is the blocked well log. Of course, when doing the simulation here in 1D, you can take the 1D model from a 3D grid, resistivity grid. You can take it from a inversion result, or you can manually type in your model. But in this case, let's use a well log. So I'm going to start the bridge plugin from the Blueback icon over here. I'm going to start by creating the simulation input. So I've given it a name, 31212 model, and I choose to store my model in a folder. I claim set here that it's a 1D model, and as you can see, you can also create a 2D model or a 3D model. I'm going to use the position of the well to give the 1D model a position in space, and I'm going to set the water depth using a seabed surface. And then here is the place where I enter my blocked resistivity model, this one here. And here you could also add a grid property, any well log, a seismic volume representing a inversion result, or you can also go for manual input. So that's it. You just press apply and this creates in a second. Next step is to go to the simulation itself. Here I choose to go for 1D simulation, and as you see we have 2.5D and 3D forward modeling too. I'm gonna add my data to a tow line. We can call it test 1D model result. I'm going to add it to an existing survey node data. I'm going to pick my model I just created, and I can set a line direction, can specify the frequencies, the offset I want to work on, and which spacing. I also you could do more advanced settings here, but typically that is not necessary. So you just run apply, and it calculates fairly quickly. Now we can go back to the 3D window, and now I have a new tow line here. This line here represents my tow line, and this box here is the receiver position, and here is my result that I just calculated. So here we can see the magnitude versus offset for this receiver here. We also have a specific EM window, which I'm going to open here. Now you can get a better view of your result here. Here you can see the magnitude versus offset, and this is the phase versus offset for that receiver. Now I've calculated the response from a model which has very high resistivities here. So typically you also want to calculate the response from a kind of a background model. We do that in this case by opening Bridge again, and I have this 1D model editor, and I can take my model here, and you can mark the lines that you, so here you see you got the high resistivities in this area here, up to almost 4,000 ohm meters. So what we do here is we're gonna replace these layers with one layer of resistivity 3. Merge the selected layers. Now I got only one, but the thickness here is conserved. I store this data, this model, in a background model to have it accessible. Then I can go back to my simulation here again. Now I'm just gonna store my results to the same tow line. So I'm not creating a new one. And instead of using this model, I'll run the background model. And as you notice, you can run several of them at the same time if you want to. I use the same settings and I do apply. Now we can go back to my window here, and I can turn on my background data here, and I can remove the phase to make it more clear and view all. And you see there's a dramatic change between the background data, which has no high resistivity, and your other resistive target. And of course you can view your models in a 3D window, and you can also choose to create a well log from your models. Now I got a new well actually. Yeah, so here's a new well. If you go back here, I can turn on this well too, and then turn on the resistivity for that. And this, I can go and color edit it. Now this goes from 0.01 up to 3.2 or 3.3 ohm meters, where the scale here goes up to almost 4,000. So the scales are very different. Yeah. Now, to continue, you would typically normalize your data to create a normalized magnitude versus offset, but that I'll show you in another session. So, thank you for your attention, and please contact us if you have any questions regarding the Bridge electromagnetic plugin. Thanks.